Let's create a wizard class with the fields name, Hogwarts house, and the birthday. Now let's say we want to add an ID field to uniquely identify wizards, but we don't know exactly which type will be this field ID. For example, we can use only name, for example, from here, for example, Harry Potter. Also, we can use name with concatenate with a Hogwarts house, Gryffindor. To separate another student with the same name, Harry Potter, is studying in a different house. And just to be sure, you can also add this field birthday. We can see that this is a type string in quotes, but we may not know exactly which type we will use, string type or maybe long type, and it will some long number instead of string. Or integer type. Not long, integer. Or some special type like UUID, for example. UUID with some random UUID. So in such situations we can use generic types. We know which type will exactly, and just write T. Type for ID for this field. This is generic type, and if a class have a generic type, the class itself must specify it with generic type. Angle brackets and T. Or other letter H, but usually use T. In elements, in arrays for elements, usually E for maps, key and value 2. In classes usually use T. And let's create a getter and setter for this type. Alt insert getter setter for ID. And we can see get return type, this type of T. Return get, and for setting in parameters we can see ID field with the parameter of T type. Okay, and let's create an example, an instance of this generic class. We specify the class name, and we can see that we needed to specify some generic, some type of ID field. Our type will be long, for example. So object is Harry, new constructor wizard, and if we write here, we can't write here, it's redundant. We can see replace with this called diamond syntax. Also we can but we must specify the type explicitly if we use var. If we use var, we can't write like this, use long. But if we use this syntax instead of var, if you will specify the type, we can delete this long. Okay, and let's create its objects. Let's initialize its value fields. So ID will be Harry Potter. We don't create a constructor, So we will use setters. Harry House is Gryffindor, and ID. Let's use ID. ID is a type of long, so we can't write some string value. We must to write long value. One long. Also, we can use any other type instead of long, string, for example. String, and here this number in string, or with name and house, for example. We just write its name and concatenate with the house and with some example, for example. With some random integer for ID. Okay. So if we need to limit generic type from above to only numbers, instead string, only numbers, for example long, we can use the same syntax. We open our class and just write here extends and class, which will upper bound number. So here we can't write string or other class which not extensive from number, which is not a subclass of number class. String cannot use UUID, for example, special library cannot use, but if we write long, we can use it. It's not a problem, because if we open its realization, open class extends from number, so it will work well. It means that in ID field we can write only numbers, only use class which extends from numbers. Integer, for example, we can see that integer 2 extends number class. Let's try to use double .2, for example, and let's open double implementation. Double extends number 2. We have set the upper bound wizard. This number class is upper bound, but now let's set but also we can use set the lower bound for type long, for example. In order to, here will be only type longer without fractional part, only integer numbers of type long. For this purpose we just write super and specify type long. It throws some mistakes. Okay, let's use a wildcard. Here we can use wildcard and specify that super long. This is lower bound long, and this is upper bound number from long to number. So if we write integer, for example, it make mistake. ID type to int, change field. Int, we can see required type. Capture of wildcard super long. Long is a lower bound, Number is a upper bound from long to, so we can not specify. We can specify a fractional part. We can use only long type. The syntax is called wildcard. Wildcard, super long. Let's set an birthday to. It's not string, it's a date, or better local date. Local date of year, month, and day. So generics were introduced into Java from the 5th version. And in order not to introduce new keywords and not to break already written programs, it was decided to use existing keywords, keyword super and the keyword extends. As you know, Java declares the motto, written once, always executed. Executed always. Now the task is for you. Find an encapsulation violation in this generic class wizard and fix the code. The possible solution: private keyword for name, house, and birthday, and also for ID. And user setters: set name Harry Potter, set house Gryffindor, set birthday local date, and set ID this number. Good job! See you in the next lesson.